Hello everyone and welcome to this session, and thank you for tuning in. Let's have a look at supervised classification within eCognition Developer. What is supervised classification? This is a classification technique that utilizes samples for each class to be classified. So you need to have somehow samples, create them or already have them as a vector or something, and then you can use this approach. We're gonna keep it simple. In our example, we're gonna have 3 classes, and I'm simply gonna show you the principal workflow. In eCognition, you're not only able to use spectral information, you also can use geometrical, textual or topological information. So way more information than on traditional supervised classification approaches where you only use pixel values. That's the basic workflow. So you need to create samples, then you train a model, and then you apply the model. And then your object's gonna be classified based on your samples that you've created. I'm gonna show you 3 sample creation methods. First one is creating them manually. Second one is if you already have your samples as a vector file, you can load the vector file and convert it to samples in eCognition easily. And third, if you do have a raster as sample input, I'm also going to show you a way how you convert this to samples within eCognition, so eCognition understands that those are samples that you want to use to train a model. Currently, we are supporting 5 different classifiers. We have base, KNN, SVM, decision tree, and random trees. And they all can easily be used in eCognition to classify your image objects. But I will show you that when we develop our rule set. So let's jump right in and have a look how you can use supervised classification in eCognition to classify your image objects. It's going to be straightforward, not very complicated, so enjoy. Alright, so this is eCognition Developer 10.2, and I first gonna load some data. You also can use your own data and follow along, but I think it's easier if you use the same data set as I do. So in the data folder, you're going to find a data TIFF file. And now I'm going to switch to the rule set development layout. I'm going to rearrange the windows a bit, and you see we have 4 bands. Layer 4 is near infrared. And this is red, green, blue, and then near infrared, right? Let me see, yes. All right, first of all, what I want to do is I want to create or compute additional index layers. And I want to compute the NDVI and the NDWI. And that's going to be used as input for the supervised classification as a feature. So please right click here in the process tree, add new process, and I'm gonna look for the index layer calculation algorithm. And here it's fairly easy because you can choose here which index you want to calculate. I'm gonna start with the NDVI. Then you define the red layer, and in our case that is layer 1. And near infrared is layer 4. And that's gonna end up in this output layer, the NDVI, undefined value is going to be -1 and so on. So you can leave that default, and here you see we have this layer as additional layer in our view settings. This is a temporary layer, so it's not saved to the hard drive yet, so just keep that in mind. And for the NDWI, simply going to copy and paste this process here, copy, paste, and I'm gonna change the index to NDWI, which is an index for water, and we have to change the green layer to layer 2. Keep the rest default, execute, and then we have the NDWI. High values for water, low values for non-water, or negative values, right? You also could rename the aliases here if you like. If you're lost now, but I'm gonna keep it as this. Layer 1, again red, and then green, blue, and near infrared. Now I'm gonna stop. 2 index layers are enough, and now I'm already starting to structure my rule set to better keep an overview. So I'm gonna create a process, add new process, and type in here supervised classification, plain color. Classification, hit OK, and that's going to create a structural process. And if you right click on this one and choose insert child process, it's going to insert a child process, and I'm going to call this index layer calculation. And now I'm going to put those into that folder, into this parent process. You can do so via a right mouse click, drag and drop. Right, it's gonna insert it onto the process you drop that on, and left mouse click, it's gonna align it below the process you drop it on. So first section is index layer calculation, and actually you now simply can delete those again and rerun the whole thing. That means you execute the parent process, and all child processes gonna be executed in a consecutive order. Execute, and there we go. First step done, index layer calculation. Please try to also replicate this one. You can pause the video and then continue afterwards. I'm simply gonna continue now. Next, we want to do or have a look at segmentation. We're going to create image objects. So I'm going to create a parent process called segmentation. And actually, you don't have to create those structural processes, but it helps you to keep the overview, and it also enables you to execute one process, the parent process, and then it's going to run the whole workflow. Segmentation. Let's insert child process, and we're gonna go for the multi-resolution segmentation. And we're gonna keep it simple. We're only gonna change the scale parameter to 20. That's it. Hit execute, and that's gonna create a level, an image object level within a few seconds. And there we do have objects. If you click on them, they're highlighted, in my case yellow. In your case, probably red. You can change it here under object levels, here in the view settings, highlight colors and change it. I simply prefer yellow, but that's up to you. All right, so we do have objects now, and now we have to create samples somehow. First way to create samples I'm going to show you is creating samples manually. So if you don't have samples yet, you simply can select some very interactively here in eCognition and then use those samples. We're gonna have 3 classes: water, vegetation, and no vegetation, which is more or less this sealed surfaces and also the background. And then we're gonna try to run a supervised classification and classify the whole scene. So first, let's have a look at how to collect samples manually. What we first have to have are classes, right? So in the class hierarchy, you simply can right click and choose insert class. Again, we're going to keep it to 3 classes. No vegetation. Create another one. Water. Going to change the color here. And yet another one. All right, and you have to do this if you want to select samples manually. Now we do have the classes. Now we can select those samples. To do so, please open the samples toolbar. You can do so via right-clicking here in this header. Right-click and then toolbars sample. You get some tools here. We're going to focus on those 2 on the left, select sample, and this brush selecting tool for samples. To select now a sample for water, you need to select the class here in the class hierarchy. Simply click on it, left mouse button, and then choose, for example, the select sample tool. And now if you double click onto an object, it's going to be selected as a sample. If you choose the brush tool, you can brush and select a lot of samples. Right? And the same for vegetation now. So select vegetation. I have the brush tool, and we do have some vegetation down here. Same for no vegetation. Gonna go for the single selecting tool. So double click on some areas that you think are representative of that class. And if you want to remove a sample, simply double click it again, right? And it's gonna be removed. We can get some information about the samples in the object information window. If you right click here, select features to display, and let's search for samples. So we do have number of samples, supervised sample statistics, classes, and feature space. They are not very interesting. I'm gonna right click on this create new number of samples, because that's per class, because I want to know the samples per class. Right? And I want to have it for no vegetation on the new level, and also for water and vegetation. So I simply can right click here onto this one and say choose create for all classes, and now I'm gonna select them and hit OK. And now you see we have 14 samples of no vegetation, 0 for unclassified, 28 for vegetation, and 30 for water. Let's see, I think I selected more. This one. Samples. Number of samples. So that should be the total number of samples, right? And yeah, those are going to be helpful further down the road if you're using sample statistics. And that's going to be part of a more advanced tutorial here in video format. Simply have a look on our YouTube channel if it's there already. If not, please give us a few days to create it. Okay, good. Sample selection done. Now we can create a model and train it. And that's very simple. I'm quickly gonna create a new structural process. Simply gonna call it Supervised Classification and insert a child here. And now we're gonna look for Supervised Classification. Now it's important here, operation, first you need to train it before you can apply it. Configuration is a variable that you create where you're gonna save the trained model. And you always can reuse this variable, right? So this trained model is saved or stored in this variable, and then you can simply use that one. I'm gonna call it model_01. Then you need to define that this is a string variable. I think double works as well, but string makes more sense. Use samples only, change this to yes. Otherwise, it also would include classified image objects. Currently, we only have samples, so we don't have classified image objects. Those are two different things, right? And I can prove this via changing here in the view settings the fill. You see here, the fill is currently samples. If I switch to class color, you see there's no object classified as anything. We only have samples. So you can have unclassified image objects, but samples, and that's a nice thing about samples because you can display your samples and classified image objects and compare those, right? Let's go back to this process, supervised classification. Use samples only, yes. Source, you can choose object-based, layer-based, and sample statistics-based. Object-based, you can use all the features that objects have. You can use the shape, the length, neighborhood properties, and so on. Of course, spectral features and statistics, standard deviation. Layer-based, you are doing a pixel-based classification or supervised classification, right? So it's using only the pixel values of the layers that you define here. And then we have sample statistics based. That's again going to be part of a more advanced video because you can create, based on the samples, you can create a table more or less, which you can export, and we call this sample statistics. You can create those in eCognition, you can export them and import in other projects and so on. So yeah, that's how sample statistics work. But we're gonna stick to object-based, and now we can select the features. We're gonna keep it simple, and we're gonna go to object features, image layer mean, and we're simply gonna use all our input layers and the NDVI and NDWI. So the index layers that we've calculated previously. Then classifier, choose here which classifier you wanna use, base, KNN. And depending on the classifier, you have different options, right? Decision tree, random trees. Let's go for support vector machine or KNN. Support vector machine, why not? And one more thing that we need to change is the domain to image object level. And now you can hit simply execute. There we go. You think nothing happened, but something happened. You also see the variable here that we created, model 1, and some information in there. So all the information of the model is stored in here as XML code. And yeah, now let's apply it. Copy and pasting this, that's the easiest way, I think, if you not want to do any mistakes. Copy and paste this supervised classification process, and now the only thing I'm going to do is change the operation here to apply, keep the rest default, and hit execute. And I now can show you that you can display samples and classified objects in one go. If you go to window, split horizontally, I'm going to switch it and display the classification on top. So I'm going to change the field here to class color, and you see we've classified something. I see some misclassified objects, but we're gonna take care of this in a second. That highly depends on the samples, right? Maybe what I'm gonna do is, I think this is water too. I'm simply gonna select some water samples here. So water, and I'm gonna use the brush, select more samples here that represents water. Gonna execute a train model again, and then the apply, and there we go. So the results are highly dependent on your samples, right? And I think this already looks all right. Traditionally, some misclassified objects here. I mean, those are shadow areas, and they are quite often confused with water, but we're gonna take care of this now in the refinement. And you're gonna see the advantage of using objects instead of pixel values, because they have been classified due to spectral similarity, but we easily can get rid of those based on the size, for example, and the context. Let's go into the refinement. First, I'm going to create a structural process here, call it refinement. And what I first want to do is I'm going to copy the level one above. So I want to do the refinement on the top level, and I want to keep my initial classification results and also my samples on this new level. Could have renamed that, but let's create a second level above our new level. And I'm going to copy copy the new level above to, let's call it simply refinement. Refinement. Execute. And now we do have 2 levels, and we're gonna change. Oh, didn't want to do that. Ah, this one. That's not a water sample. All right, let's have a look. So we do have a lot of small objects, right? Just gonna put that into the refinement. And now we have 2 levels, and we only wanna take care of our objects on top level. Only wanna refine them and keep the bottom level because we have the samples at the bottom level. The advantage also is that, or what happens if you alter here objects that are samples, you're gonna lose that sample, right? Because you're altering the object outline. And you can overcome this issue if you copy the level and simply work on the refinement level and keep the samples and the initial classification on the bottom level. Alright, and because we have small image objects, I'm simply gonna run a merge region. Make sure you're on the refinement level, execute. And now you see this one became one big object because we had a lot of small objects classified as vegetation touching each other, but we merged them together. However, we still have our objects at the bottom level because we are working on the refinement level. Now I want to take care of small misclassified objects like these water objects, and I'm going to use the remove objects. And class filter none, level refinement, condition. I want to remove objects or dissolve them into their surroundings if the area of the object is small. And I'm gonna go, in this case, for 600 pixels. That always depends on your scene resolution and the pixel size. In this case, it does the job, I think. Leave the rest default, execute. And that already looks way better. We still have some issues here with water. How can we solve this? Contextual information, right? This object, for example, this water object is 100% surrounded by urban. So we're gonna use that information. I'm quickly gonna display that feature that we're gonna use here in the object information window. And I'm gonna look for relative border 2, this one here. I'm gonna create it and choose urban. So, well, urban, this no vegetation class. So give me the relative border of my object to the class urban. Let's have a look here. You see, this water object has a relative border to no vegetation of 0.1435. And what about this one? This one has 0.4. This one has, oh, 9.6, didn't expect that. But eCognition doesn't lie. Ah, it's because it's at the scene border. Okay, makes sense. How can we get rid of this, or how can we implement something that takes care of that? Actually, I'm just gonna copy this remove objects and say look at water and dissolve water in the surrounding if that relative border, where is it, up here, to the no vegetation is greater or equal to 0.4. And that should dissolve those two into the surroundings. In this case, it's this red class. Okay, that's it. Now we can export our results. First, I create a structure process, and then I'm going to insert a child and look for export. We do have a lot of export functions that you can choose from. I'm gonna export it as a vector layer, and yeah, class filter none. It's important that you set it to refinement, so the refinement level is exported. You also can limit or filter the class that you want to export here in the domain settings. And then what else is important? Yeah, shape type, point, lines, polygons. I think polygons make most sense here. Then you can also choose export format, shapefile, file, geodatabase, GeoJSON, and so on. If you export this, the class name will be added as an attribute in the attribute table. You also can add any attribute here from this list. Right, and I simply can show you actually if you want to use a different classifier. We use support vector machine. If you want a different one, I'm simply going to remove the refinement level. Yes. And now again, let's have a look here at our samples. If we open this train section, the supervised classification algorithm where we train, we simply can change this to, for example, base, and write it into the same configuration. That's going to override that model. Execute this one, execute, and you see we do have slightly different results. Let's look here. We do have some red areas here, and now we simply can run the refinement, copy it one level above. I'm gonna change this to black. First, we're gonna do merge region, and it might also clean up our settings that we defined previously. So everything that's smaller, we still have some leftovers of no vegetation here, but that might just be true. And this relative border thing, that doesn't make that much sense in this case, because you saw water vanish because the relative border to the vegetation in this case was, let's do it again. Was greater than this 0.4 that we've defined. So in this case, you would need to adjust this a bit. In this case, it's 0.6 for water because we have the small no vegetation objects here. All right, but you get the idea. You're very flexible here. You can change the type easily. You can manipulate the samples, and maybe also something that is interesting is this tool here, 2D feature space plot, where you can plot, or you see samples compared to declassified image objects, for example. And we gonna go for the new level, and we're gonna plot here on the y-axis. Let's go for the mean NDVI, and the x-axis we're gonna use the NDWI. All right. And there you see your classified objects. In red, this is no vegetation, here vegetation. And if you look closely, you see also the samples that are related to those classified objects. The samples are displayed here in these circles, and the classified objects as crosses. So you might see some outliers, or you see some samples that are not fitting, so you can remove those then and run the supervised classification again. Okay, now we're gonna save this rule set, right click, save rule set as, and we're gonna save it somewhere where you're gonna find it again. Gonna call it supervised classification manual. In the next 2 minutes, I'm simply gonna use the same rule set and adjust it to having samples as a thematic layer already, and that's gonna be easy. Okay, how does it work if you want to simply use, or if you have a vector that you want to use as samples? I'm gonna delete all my levels here, and DVI as well. And you can use the same rule set. I'm simply gonna alter it a bit. Gonna add a new section here called samples. After the segmentation, so we computing NDVI and NDWI. we create image objects, and I have prepared a calibration shapefile, so a vector with our sample information, and I'm simply gonna load it. So insert child process here, and you can choose create modify project, this algorithm, and you can load files here. You also can drag and drop it, but the advantage here is that it's you can automate it, and yeah, simply browse here thematic file in the data folder for that calibration shapefile. So you only need to select this one, calibration.shp, hit open, and then you can define already the alias here. Instead of thematic layer 1, I'm gonna call it calibration. Execute, and that's gonna load that into eCognition developer, and you see those crosses, those are my samples. Now we can use an algorithm called convert thematic objects to samples, and that's going to create samples based on our thematic layer. Your thematic layer can be polygons as well, or lines. It's also going to work. And for polygons, you can define here overlap requirements and so on. Let's keep it simple. We are on the new level, and the thematic layer we want to use is calibration. We want to use this column in the attribute table. There's only one class, calibration. And important is here match class name. So you might have different naming in your vector compared to the project naming of the classes. If that is the case, you simply can change it here on the fly. So in our case, input value is water, so that is the naming in the attribute table of the vector, and it was automatically mapped to water here in the project because the name is identical. For vegetation it's different, so we need to change that to vegetation. It's just here it's capitalized, and urban is our no vegetation, right? And it does this connection automatically now. And I hit execute. That's it. Let's display the samples. And you see we've created samples based on our thematic layer. That was easy. Now we can run the supervised classification again. I'm going to change here to support vector machine. Execute. That's our result. Let's do the refinement. Right, that's the result using a thematic layer. Now I'm gonna quickly delete the image object levels again, and also remove the calibration. And I'm gonna show you how that would work for a raster. Let's remove this. And there's also a raster layer in here, calibration 2.tiff. Open that one, and we're gonna call it calibration. Index layer creation, run this again, segmentation, and then loading the raster. I already executed it, you see it here. It looks like this. Now what we have to do is convert those somehow into samples, right? And the workflow is the following. I'm going to use the multi-threshold segmentation on the image object level using this calibration layer. And I'm going to define the classes here. So I need to play around, actually. No vegetation. 1, 2. So I'm assuming that values of 1 are no vegetation, 2 is water, and 3 is vegetation. Let's see if that is correct. See, all right, I missed that. So we also have the value of 0, 1, 2. No vegetation. Let's see how that looks like. Okay, so this is red, so water has to be switched. So everything that's no vegetation is actually water, and this is probably no vegetation. Yes, there we go. So that looks good. So those are now classified image objects. And instead of convert thematic objects to samples, I'm gonna use convert classified image objects to samples. Simply hit execute. And now I have converted my classified image objects derived from the raster into samples. And if you switch to the samples view, you're gonna get this result. Gonna run the support vector machine and the refinement. And yep. This is the result. Same as before, more or less, but now the samples were implemented or imported as a raster. And you actually can use the same workflow if you already have, for example, classified objects and you decide to use those classified objects as input for supervised classification, so as samples. You simply can use this conversion algorithm to convert the classified image objects to samples and then train the model using these samples. Alright, that's it. I showed you how to create samples. There's more regarding supervised classification. Have a look at our YouTube channel and look for supervised classification. You're going to find more material there. Thank you very much for watching this one. If you have questions, post them in the community and enjoy using the supervised classification in eCognition Developer. Thank you very much. Bye bye.